Hi, I hope you're doing great. This is the 7th video on SQLite, and in this video we're going to talk about group by. And group by is a way of aggregating information, and personally, this is my favorite SQL command. It is incredibly useful for aggregating information or for showing trends in the data that we have and so on. So let me take you through this by jumping into the code and getting started. So here we are in the code, and I just want to point out that I've actually added another song that we didn't have the previous time. This is Born in the USA by Bruce Springsteen. And the reason I've added this row is that now we have two songs from the same artist, and that's kind of nice for visualizing grouping by or aggregating. So this is basically the same code we've had previously, so let's jump in here. And now we can talk about aggregation. And aggregation can help us answer questions about aggregate information in our data. So one question we could answer is how many songs came out each year. So this is a question we can have, and since our database only has 6 songs now, we can just basically count ourselves, say, okay, we have 2 songs from 1984, 1 from 1982, 1 from 1985, and 2 from 1987. Great. This manual counting only works when you have really few rows. So imagine that this song database have 100,000 songs, then this is definitely not feasible to do, and we need to aggregate this up automatically with a SQL command. And the SQL command is group by. So let's start writing this out. We have a selection that we want. We're going to the cursor and executing a command. So nothing here is really very new. And afterwards, we're going to fetch all of them. So now I can write our SQL commands here. So I want to select year first, and I'll select something else afterwards. And then from songs from the 80s table that we have. And now I want to use the new command, and this is group by. And now I can group by year. And that means that the output, instead of representing each row, it will represent each year. Where in each row, I also want the information about how many of these songs that we actually have corresponding to that year. And to do that, we need to use an aggregate function as well. So this is kind of paired. You have a group by statement down here, and then you pair it by saying what you want to aggregate. And I want to aggregate just counting up all the rows. And this I can do with the following syntax. So this is the count function. This counts, and this just indicates that you can count all the rows. So if I have this selection, then I can just print it out. Let's just call this songs per year. Print this out. And here you can see now 1982 has 1 song, 1984 has 2, 1985 has 1 song, and 87 has 2 songs. So this gives us this aggregate information automatically. And imagine if you have 100,000 songs, then this would be super convenient for visualizing, say, perhaps a histogram or a bar chart displaying how many songs came out each year. So I think one way of getting the hang of a group by statement is simply to modify the information a bit. So let's just copy all of this to have a new version here. And instead of thinking about songs, we can think about number of songs per artist. And as we saw previously, I actually added the Born in the USA song from Bruce Springsteen, so we kind of expect 2 songs for Bruce Springsteen and 1 song for the other artists. So what do we need to do? So first of all, I think it's easier to think about a grouping statement. We need to group by artists, because we essentially want to have artist first and then how many songs they have. So here we need to kind of reflect this by picking the artist, and then the count. That's perfectly fine. We simply want to count it up. So here we have it. Now maybe this is a bit misleading. Let me just say songs per artist. And here we have this. So Bruce Springsteen has 2 songs and the other artists has 1. You can see if we try to remove the artist here from the select statement and run it again, that's perfectly valid. So this is a valid SQL command, but then you just get back the aggregation information. So now it's not so easy to see what this 2 corresponds to. So typically, very often at least, you want to also select the column that you're grouping by, so that when you're doing this, you get the information nicely like this. There are so many cool things we can do with a group by statement. I just want to show you a few kind of basic variations of this. So one thing we can do in addition to asking about counts is asking about averages. So again, let me copy this and modify it a bit. Now I want to think about average song length per year. So again, we have a selection statement. Now it's really the year again that we're grouping by. So we want to have year, and then we want to have the average length of each song. And as you might expect, in addition to the count function, we also have an average function. And now we want to not take the average of all of this, that doesn't really make much sense, but we want to take the average of a numerical value, and that value is the duration. Now let me just alter this statement. And if I run this, so we see that from 1982, the average song is almost 5 minutes. And then there is some variation in all of these. Probably here the variation is much greater than what you would get in a kind of real songs from the 80s dataset, simply because we have so few representatives from each year. But still, this is also kind of cool to visualize and to see when we're thinking about songs from different areas of time. Have the length of the songs gone down? Have they gone up in average, and so on? Now let's just modify this a bit in an interesting way, because we got back 4 of these, 1982, 1984, 1985, and 1987. But we might think that if you only have one representative from the year, then that's not enough. You really need to have at least 2 songs to say something kind of interesting about the average. So what you can do is add another clause under the group by statement, and this is called having. And then you can ask for that, for instance, that the count should be greater or equal than 2. So if I save this and run it, then I'll only get back 1984 and 1987, because that's the 2 years where we have more than 2 songs representing it. So this is, I guess, also a new keyword. The having keyword is kind of always tagged along with the group by keyword. So if you group by, then you can afterwards do a having keyword here and then have a condition. And that condition can be anything as long as it is a valid condition. And immediately when I think most people learn about this, at least for me personally, when I learned it many, many years ago, I was thinking about this having condition and thinking like, isn't this just the where condition? Isn't this kind of the same? It's selecting based on a condition, and that's completely true, but they have different use cases. Because the having clause, that selects after you've grouped, while the where condition selects before you start grouping. So what I can do with the where condition here, I can add that as well. Let me just go here. I can add a where condition and say that, yeah, the year should be, let's say, greater or equal than 1985. And run it, and then we'll only get this 1987 year. So what's happening is that first the selection is done, and then the where clause is applied. So we're only considering the years that are higher than 1985. Then we're grouping it, and then we're saying, yeah, after the grouping, the counts for each of these aggregations should be more than 2. The essence is that the having keyword is always kind of tagged along with a group by keyword when you're aggregating, and then afterwards want to kind of filter down. And now we've learned quite a lot of different expressions and clauses, and there seems to be some kind of order here that needs to be followed, and that's completely true. And I just want to point that out, that again, the order of expression matters. And here I just want to paste in kind of a very big example so that you can see a large one. So let's see what's happening here. So we're selecting year, and then we're also doing the count and the average from the songs. Then we're asking that the year should be greater than 1980. Then we group by year. Then we're saying that, yeah, the count should be greater or equal than 2. But then we also can have an order by statement. And now we can order them by year. So the order by needs to be after the grouping, simply because ordering it is kind of the last thing you do. So you do the grouping and then you order them by the year, while otherwise, if you do the ordering beforehand, that's not really valid. And also it wouldn't really make much sense, because then you're ordering it perfectly and then you're just grouping it by kind of messing up all the order again anyway. So that wouldn't really make sense. And finally, there is also a limit keyword that you can use. We haven't talked about this, but this essentially says, just give me the first one. So if I run this now, you can see here the average song length per year after 1985 for years with more than 2 songs. For the text to make sense, this should be 1985, like this. Run it, and now you get this precise element here. And that corresponds to the average song length for a year after 1985, where you have more than 2 representatives for that year. So you can make really, really powerful SQL statements as long as you obeyed by the order that they need to be in. So that's all I wanted to say about the order by statement. Again, it's a kind of personal favorite and it's super useful for getting kind of a deep insight into your data. In the next video, which is going to be the final video on SQLite, we're going to talk about joins. So far, we've only worked with a single table, but databases, they typically have many tables. So in the next video, we need to combine information from different tables so that we can get a really powerful combination effect. As always, thank you, and I'll see you again next time.